All right, here we go. We're on number 7. 7 on the supplemental problems. This says during a chemical reaction, 4.032 grams of hydrogen. 4.032 grams of hydrogen. I'm just going to write H for hydrogen right now, even though I know that that is technically incorrect, but just for where we are right now. Combined with oxygen. All right, so it doesn't tell me how much oxygen. So I'm going to say grams of oxygen. It doesn't tell me how many. To form, all right, to form 36.032 grams of water, H2O. How many grams of oxygen reacted? So do we see here, this is the law of conservation of matter, or conservation of mass. So we know that the mass of the reactants has to equal the mass of the products, right? So we have 4.032 grams plus an unknown amount of grams equals 36.032 grams. So if we're adding, then we're going to subtract 4.032 grams from both sides. That's the algebra of that. Grab your calculator if you aren't comfortable with that. So the grams of oxygen, how many grams of oxygen was that? When we do that, we are going to get 32.000 grams. And yes, we need to put all of those zeros in because those numbers were precise to the thousandths place. So that's helping us practice our sig figs. So the amount of oxygen was 32 grams. All right, let's go on to question number 8. All right, in question number 8, it says, now here we have a chart, okay? So let me pull this over. I'm sorry, it's going to get, there you go. There's our chart. So let me just read it from here. This says, so you can understand what I'm going to do. So it says that we have nitrogen and oxygen combined to form different compounds. So the fact that they can form different compounds is an example of the law of multiple proportions, just like water and hydrogen peroxide or carbon monoxide and carbon dioxide. So the fact that we can have nitric acid, nitrogen dioxide, and nitrous oxide, all with different chemical formulas made from the same two things, that's law of multiple proportions. Now, it's asking us to prove that this is law of multiple proportions. I'm sorry, this is very shaky, based on the ratios. So what we're going to do is we're going to look at these ratios. So I'm going to jot those down real quick so you'll see how I'm pulling this out. So this says, what is the ratio of the masses of nitrogen in each of the following? So do you see here that this is just asking us to take what is the mass of NO2, and it has a slash, but I'm going to do it this way, NO4. So this is the first one. So we look at the chart. We just look at the chart. It says that the mass of NO2 is 0.88 grams, and the mass of NO4 is 0.44 grams, and so 0.88 divided by 0.44 is 2. That's a whole number. So yay, that works. That's what this ratio is trying to show us. We do the next one. It says NO, nitrogen monoxide, nitrogen oxide, and then NO4. We just pull the masses from the chart. So the mass from the chart is 1.76 over, and it's nitrous oxide, so that's 0.44. So if you can't do that one in your head, grab your calculator, and that should be the number 4. That is a whole number, so yes, that ratio also works. So that is an actual thing. Let's look at the third one, NO divided by NO2 to get the ratio here. So NO for nitrogen oxide is 1.76. NO2 is 0.88. So when we divide that, we get the number 2. That is also a whole number. So those all check out to be whole number, whole number, whole number. Those are whole number ratios related to a fixed mass of oxygen. You see it was always back to 1 gram of oxygen. And this was provided for. So that's how we use given information to find a ratio, right? Just do what it's telling you to do. That line says divide, so you divide them. All right, let's go on to question number 9. All right, let me flip a little bit here and let that refocus. Number 9. Question number 9 says, carbon and oxygen combine to form carbon monoxide and carbon dioxide. So I'm actually just going to, so carbon plus oxygen form carbon monoxide. And it gave us that formula in there, right? And it also says that carbon plus oxygen form CO2. All right. So now let's see what else it says. The masses of oxygen that combine with 12 grams of carbon. So I've got 12 grams of carbon, and it says I have 12 grams of carbon in each of these to form these two compounds. So 12 grams. In this one, it says it's 16 grams and it's 32 grams. And there's that beautiful word respectively. That's how I know that the 16 gram goes here and the 32 gram goes here, because it's talking about that. Then it says, what is the ratio of masses of oxygen in, so I'm looking for mass of oxygen in when I compare CO2 to CO. All right, so let's look at what we have. We have some masses available to us, right? So this is a fixed mass. So I don't have to do anything. These numbers are the same, so I can just compare these two. So notice how it's set up here. I want my masses here to go in the same order as these. So this is going to be 32 grams of oxygen and 16 grams of oxygen, right? So 32 divided by 16 is 2. Checkaroo. That shows that these are actual compounds. The law of multiple portions is observed because these are happening in a whole number ratio. If this was not a whole number, then we would not have the correct ratio happening, all right? So while we're talking about law of multiple proportions, let's do one more problem related to this. This is question number 10, okay? So let's look at question number 10 here. Question number 10, let's read it. It says phosphorus and chlorine. So phosphorus is the letter P. That's how we're going to represent it. So phosphorus and chlorine. And I happen to know that it's Cl2, and I can't hardly make myself not write it, but that's okay. Combine to form two different compounds. So I'm just going to call them compound 1 and compound 2, right? And I've got 1, I've got carbon, and it's doing this, compound 2. So compound 1 and compound 2. So now let's see what it says. In one compound, so let's call this the 1, 3.88 grams of phosphorus combines with 13.28 grams of chlorine. So I'm just reading, right? All of those words. Now, do you see how me making a word picture of this help me know what I'm doing? This is compound 1. In the other compound, so this is the other one, 1.32 grams of phosphorus combines with 7.56 grams of chlorine. And then the question is, do the data, because data is plural, do the data support the law of multiple proportions? Okay? So we've got to show that. So does this information say that we can actually make these compounds? So what we're looking for is, do we get a whole number ratio when we work through this, okay? So now, here's how we do that. Here, look. None of these numbers are the same. None of these numbers are the same. So we have to do a little bit more work here. We have to find how these numbers compare, okay? So let's do that. So compound 1, right? 3.88. This is how I see if they compare. 13.28. What is the ratio? How are these comparing? So grab your calculator, and that number is 0.292, right? So that's how those numbers are comparing, that sort of ratio. In compound 2, let's see what the ratio is. So we're always going to take the smallest one and divide it by the bigger one. 3, 2, 7.56. So we grab our calculator, 1.32 divided by 7.56. So this gets us 0.175. Okay? All right, so now all we've done is say if we to a fixed mass, that now we need to compare these numbers, right? We have to get a ratio for these numbers. So we're just going to take these two numbers now and go 0.292, right? Divided by 0.175. And if we get a whole number, then yay! Compound 1 and compound 2 are both valid compounds, and this information is all copacetic and it works. So let's see what we get. 0.292 divided by 0.175 equals 1.67. Is that a whole number? No. I can't round it up, so this is like not where I can round, right? Because if I got 2.3 blah 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 and some change, I could my 2.00, right? Then I can work with that. But no, this is not a whole number. Not a whole number. So since this ratio is not a whole number, the law, the LMP, the law of multiple proportions, has not been supported. So there is a problem somewhere, right? That the law of multiple proportions has not been supported, so it is not, both of these cannot be valid compounds. We don't know which one's wrong, but we just know that this information is not going to work out. This one is a little more difficult. And because of having to get this data first and understanding that you have to be, remember why we did that. We had to do that because none of these numbers matched. Remember in the other problem, the amount that we had here was the same. So that was already a fixed mass. So we had to get this ratio and then make another ratio from that. Okay?